Good morning, everyone. Today, I will walk you through one of the most foundational concept in the field of theoretical computer science. That is the Turing machine. So, myself, Jayashree, and I will be explaining not only the technical aspect of this concept, but also its practical implementation in today's world of computing. So the contents that I included in this PPT is introduction to the Turing machine concept and its origin, and also the core components and how they work, and then an overview of instantaneous description, and also a problem that is I give one question-based Turing machine problem that look into using these algorithms and tools we use that, and then detailed explanation of how it lies together, and also finally we will conclude with the key takeaway. So the introduction about Turing machine, that is Alan Turing, regarded as the father of computer science, conceptualized this model. But why is it so important? Because the Turing machine is essential and abstract computing machine capable of processing and generating valid strings from given alphabet. What is remarkable is that it serves as a model for the CPU, that is controlling all data manipulation done by computer today. Turing machine is theoretical. It influences is deeply embedded in the way modern day computer function. And then next thing is Turing machine. So it consists of the tuples, set of tuples, that is Q and the Q is a finite set of state, that is each state represents the configuration of machine at any given time, that is sigma, a finite non-empty set of tape alphabet symbols which are the characters the machine can read and write on data. B is the blank symbol which acts as an n-marker or separator for input. Delta, so the transition or mapping function that defines how the machine moves from one state to another based on the current symbol being read and current state. So next thing is instantaneous description. So it gives us a snapshot of what the machine is doing at any moment. It tells us the current state of the machine, and also the symbol is reading from the tape, and also the position of the head of the tape. So, okay, see here the problem statement is design a Turing machine for the language else equal to W belongs to A comma B star, and then W is equal to W power R. That is whatever string. See here. Okay. That is suppose our string is, that is W is equal to, if our string is AB, which means AB, if we reverse, that is W power R. If we reverse the string is means BA. Here it says that W equal to W power R. So if W string is, we take it as AB. So the value for this W is its reverse only. So BA. So we if we design the tape like this, so if A B our string means, our taken string means, but it accept by, that is the condition is W is equal to WR. So we take it as a reverse string also, that is BA. It's easy process only. Here if we first time we read the input as A means, just we change it as blank and move to right side up to blank. So while we reading the blank state, just we move on to the left side, and then next at moving to the left side immediately we read the A means, so we change it also blank. So and then next whatever A or B, whatever it will occur, we just move on to the right side only. So while move on to the right side, if B occur means set the B as it is, and then move on to the right side. And then so if the here starting is B, so B occur means the same process, change it as blank, and then we have to bypass this up to reading the blank statement. While we read the blank, we just move on to the same process, left side, and then change the B as blank. So finally the whole string is take as the blank only. So we change now we see this statement. So this is the Turing machine drawing tool. I suggest that here you can draw and cleanly make a note of it. And then so here consider this. See, this is the this is the Turing machines that are tuples. That is Q means that what are the states we used for the drawing the diagram. That is Turing machine diagram. Sigma is the input symbol that we used here. Input is AB, and then the symbol is that we used in the stack. That is we used in the stack symbol is A, B, and then blank. And then next is transition. That is we that this thing is how it changed, how it move or move right or left side. That the thing we will make note of it. And then next is Q naught is the start state, and then B is the this blank, and then F is the final or accepting state. So next I write this some example language that is starting. So here they give us A comma B the whole star, so epsilon also here occur, and then single A also accept B, and then A B B whether it start with A or start with B. So one right. Okay. Oh, okay, see here first starting state that is Q naught. So while we read the input as A means change it as B and then move on to right side. So that only here I write. So here A is our input symbol. We changed it to as B and then we move on to the right side. We move on to right side. So next state is Q1. From Q1 we read n number of A's or n number of B. Everything we just keep as it is and then move on to right side, and then we move bypass our machine up to we reach the blank. So while we reach the blank we just keep it as B and then move on to left side. So next from Q naught, so while we moving on to left side, immediately it occur the A means we change it as the B, and then we next move on to left side because first starting also A, because the string we reverse means see here, wait, okay, so from Q2 that is Q2 after we reach the blank here, we move on to the left side, so immediately we read the input symbol as A means we need to change it as the A to B. Then we move on to left side. So see that condition I read here. So if, in from here this state after we change the B and move on to left intermediate we see the A B so many symbols. Whatever the symbol occur we just no need to change, just move on to the left side. So here this that thing I write here. So likewise we move on to here. First we change as B and then move left. If we read the B symbol and then move left and then again move left, here we read the blank. So if we read the blank means keep blank as it is and move on to right side. So that the thing I write here. Blank read means keep blank as it is and move on to right side. And then see, and then again it the same processes occur. Here we read the B. That is the starting symbol is B. So here our for input also starting symbol is A or B. Anything will occur. So if B occur means that same process only. B change it to blank, move on to right. Intermediate n number of A or B occur means just keep as it is and then move on to right. And then while moving to the right we read the blank means we just keep it as the blank and then move into the left side. So here while moving to left side the same condition, immediately we occur the B means change the B to blank and then move on to left side. So left side we while we moving that intermediate A or B n number of A B or it occur, we just keep it as it is and move on to left side. While moving on to left side if we read the B means just to right and do same process. So this is so here what we read means for B, B. So here completely we change everything to B. So here while we change the B as to blank, okay. Change the B as to blank, that is left side, we move to B
See here will if after change is to B, if we read the input as B means keep the B as it is and move on to right. So see here while moving on to right, here we not know here we not read the input. So here is the possible to read the blank also from start state. So while we reading the blank mean it consider as that we read the traverse the entire string and then we check it. So that the condition I write here. So if we read the blank means just move on to right side and reach the final state. That the thing I write. So the same condition is also occur here. See here, if another condition is so if I traverse the string likewise, at the end I read the blank means keep the blank as it is and move on to left side. So while moving on to left side, see this condition, move on to left side. If I read input symbol only, I changed it as to B and move on to left side. So instead of I reading the input, if I read the blank, see blank I read means then we that situation also the same situation. What means we traverse the complete string. That is entire string. So and finally we move on to the final or accepting state. So this is the process happened here. Next we need to write the transition for the using this diagram. Um, Here delta of q naught comma a. See from first transition up to final transition we have to write it. First q naught the starting state and then input is a means we move on to q1 change as to blank b and then write and then move on to right side. So this is the transition. I think we discussed already in the before slide. So here first is whatever the transition we made here that only we return in this format. So first is what the current state and then input symbol and then next equal to what it move on to next state or that current state that thing and then change the input symbol and then the direction of this. So this is like this only for Turing machine the transition we want to like this only and then next instantaneous description. Here we take one input string and then process it. So here what we means the starting symbol is Q naught. I take the input as A, B, B, A. So first we reading the A means what we to do we change as to blank and then move on to right side. That is Q1 state. That is only here I write into here. That is what I write. I change it B and move on to right side. Another n number of A or B what we read we just keep it as it is and move on to right. So likewise, whatever we done here, that only we return in this description. So finally, our input string or given input string or we take an input string is reached the final accepting state means given string is accepted. So finally, we write Q means whatever state we used that only written here. Summation means that input symbol we used for this transition. And then this is stack symbol, whatever we used, and then transition we return, and then Q naught is the start and then B and then QF is the final or accepting state. So that's all. This is a simple process for every whatever the input string or whatever the condition may change means likewise we have to first draw the tape. Using this tab we analyze it and then we just think of it how to change it. The simple thing only. If we find it here means we usually draw this transition diagram. Thank you.